Hello friends, welcome back to my YouTube channel. Today we are going to solve this nice geometric puzzle. ABC triangle is placed inside the circle and it's given that AB is equal x, AC equal 2x and this ACB angle is equal to 30 degree. And we need to prove that if you remove the ABC triangle from the circle, the remaining area is equal to this one. Let's jump into the solution. I am going to check the sine value of the ACB angle. Sine 30 is equal to AB over AC. AB is equal to x. AC is equal to 2x. X over 2x equal to half. If the sine 30 is equal to half, which means ABC is a right angle triangle. Then according to the Thales theorem, when ABC angle is equal to 90, then AC becomes the diameter of the circle, which means radius of the circle is equal to x. Now I can find the area of the circle. Area of the circle is equal 5r square. Radius is equal to s, so it is equal to 5x square. Now the area of the triangle is equal to half times AB, the base times the height is BC. Half times AB is equal to x times BC. Now, BC can be found easily using the Pythagoras theorem. BC is equal to square root of AC square minus BC square. We know that AC is equal to 2x, so 4x square minus x square square root, it is equal to 3x square square root. So BC is equal to square root of 3 times x. Now I can find the remaining area. Capital A is equal to 5x square, which is area of the circle, minus half time x times the square root of x, which is the area of the triangle. This is equal 5x square minus half times square root of 3 times x square. Now if I take the common factor x square out, then x square 5 minus square root of 3 over 2. So this is our final answer. Please subscribe and hit the bell button for future videos.